Consecutive integers, integers that follow one another. We have ways of representing these consecutive integers. When we don't know what they are, we can just call one of them 1 and label it x. The next consecutive integer would be 2, and we got there by adding 1. From 1 and continuing with consecutive integers, to get to 3, we would have to add 2. So when you're working with just consecutive integers, you start somewhere and then you add 1 and add 1 more and add 1 more for as many consecutive integers as they need. When they talk about consecutive even integers, numbers like 12, 14, 16, 18, again we're going to just call the first one x. We don't know what it is, and it really doesn't matter. But if we want to get to the next number, 14, we should just add 2. To go from 12 to get to the next number, we would have to add 4. And so this pattern continues where every time you're adding 2 more than you did the previous time to get to the next consecutive even number. Odd consecutive integers do the exact same thing. Our odd numbers 1, 3, 5, 7, 9, 11. If I call the first one x, because we don't know really what consecutive number they're talking about, to get to the next number, to go from 1 to 3, I simply add 2. To go from 1 to 5, I add 2 more to that, which is adding 4. So we just call our first number something, and then we find out if we need to add 2 every time or if we need to add 1 every time. Depends on if they just say the word consecutive or consecutive even, consecutive odd. And odd and even are done the exact same way by adding 2 each time. Let's look at an example. The product of 2 consecutive even integers is 168. Find the integers. Well, they start with they want product. Product means to multiply, so I'm going to multiply 2 things together. Then they want 2 consecutive even integers. Well, let's remember that if I want even integers, the first one I don't know what it is, x, but to get to the next one I simply add 2. Then the word is my equal sign, 168. To solve this problem, I am going to clear parentheses using the distributive property. X times x is x squared plus 2x, and then I want this to be equal to 0. In order to do that, I need to add a negative 168 to both sides of this equation. Now in order to solve, since I have 2 variables, I'm going to try and factor. I can only do this when it's equal to 0. That's what makes me happy. Breaking down the first term, we have x and x, and breaking down 168. Well, that could take a while. Let's go off to the side of our paper and find all the factors of 168. 1 times 168, 2 times 84, 3 times 56, 4 times 42, 6 times 28, 7 times 24, 8 times 21, and 12 times 14, which happen to be 2 apart from each other, which is exactly what we're looking for. So we'll use that 12 and 14. Double check the last sign. It's a subtraction, which means the signs need to be different, but you need to have a positive when you're done. So I'll have a positive 14 and a negative 12. That seems to be working for me. Using the zero product property, I can set each of these factors equal to 0 and then solve that new equation. We now have x equals negative 14 or x equals 12. The 2 consecutive even integers are either negative 14, and associated with that number, since we said in our original statement that we were going to add 2 to get to the next consecutive, would be negative 12. Or we have another possibility. X could equal 12, in which case we would have 12, and adding 2 to that, our next number would be 14. So we have 2 sets of consecutive even integers that work for this problem.